everyone, my name is Namrata Verma, Assistant Professor in the Electronics and Telecommunication Department at Sri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. In previous video lecture, we discussed about the amplitude modulation, its mathematical representation, its generation and description. Today, we are going to discuss about amplitude demodulation. In today's lecture, we are going to cover the topic with the following point. First, we will see what is demodulation, then the need of demodulation, methods for demodulating the amplitude modulated wave. Basically, there are two methods for demodulating AM wave. The first one is square law demodulator and the second one is envelope detector. And then method of demodulating the double sideband suppressed carrier wave. Again, there are two methods for demodulating DSB-SC wave. First one is coherent detector and second one is Costas loop. Now, first we will see what is demodulation. The process of extracting an original information from the modulated wave is known as detection or demodulation. This process is the reverse of modulation and is used to recover the original signal from a modulated signal for further processing or further use. The circuit which demodulates the modulated wave is known as demodulator or detector. The modulation and demodulation are the two important processes in data communication. Both of these processes contribute to the success of communication by transferring data and information with minimum distortion, losses and efficient use of spectrum. The modulation process is being performed at the transmitter side while demodulation is being performed at the receiver side of the communication system. The electronic device which used to perform modulation and demodulation is known as a modem. It modulates or demodulates information while it is being transmitted. Now, next we will see what is the need of demodulation. Modulation is used at the broadcasting station to send the audio signal over longer distance to a receiver. Whenever the modulated wave is acquired by the radio receiver, the audio signal must be recovered. The wireless signal is made up of carrier wave modulated by radio frequency. A telephone receiver's or a loudspeaker's diaphragm cannot vibrate at a high frequency and this frequency is outside of the human's ear audible range. As a result, audio frequencies must be separated from radio frequency carrier wave. There are two methods for demodulating the amplitude modulated wave, or we can say there are two demodulator or detector for demodulating amplitude modulated wave. The first one is square law demodulator and second one is envelope detector. Now, first we will see the square law demodulator. A square law demodulator is used for detecting amplitude modulated signal of a small magnitude which is below 1 volt so that the operating region may be restricted to non-linear portion of the VI characteristics of the device. It is a non-linear device that generates an output signal which is proportional to the square of amplitude of input signal. The block diagram of the square law demodulator is shown in the figure. It may be observed that the circuit of square law demodulator is very similar to the square law modulator. The only difference is that in the square law modulator, a bandpass filter is used, whereas in square law demodulator, a low pass filter is used. The amplitude modulated signal is applied to the square law device. Here, diodes are used as a square law device, and then the output of a square law device is passed through the low pass filter. The low pass filter is a combination of resistance and capacitor that only passes signal below its cutoff frequency while rejects all the signal above it. This low pass filter will pass only low frequency modulating signal. Let the AM wave V1T is applied as an input to this demodulator. The standard form of AM wave is given by V1T is equal to AC into cos omega CT into 1 plus Ka cos omega MT. Give it equation number 1. The mathematical relationship between the input and the output of square law device is given by V2T, that is equal to K1 into V1T plus K2 into V1 square T. Given it equation number 2, where V1T is input to the square law device, which is nothing but the AM wave. V2T is the output of the square law device. K1 and K2 are constant. Now substitute the value of V1T from equation 1 in equation 2, then we get V2T is equal to K1 into AC cos omega CT whole is multiplied by 1 plus Ka cos omega MT plus K2 AC square cos square omega CT whole is multiplied by 1 plus Ka cos omega MT whole square. After expanding this above equation, we will get V2T is equal to K1 into AC cos omega CT plus K1 into Ka AC cos omega MT into cos omega CT plus K2 into AC square by 2 plus K2 into AC square by 2 cos 2 omega CT plus K2 AC square into Ka square MT whole is divided by 2 plus K2 AC square Ka square M square T whole is divided by 2 cos 2 omega Ct plus K2 AC square Ka M square T plus K2 AC square Ka Mt cos omega Ct. The above equation is passed through a low pass filter which will pass the frequency up to omega m and the DC component, and the high frequency is eliminated by this low pass filter. Therefore, at the output of low pass filter, we will get K2 into AC square into Ka square Mt whole is divided by 2. From this output, we can observe that it has m of t, which is nothing but the modulating signal with frequency Fm or omega m, and the constant K2 AC square Ka square by 2. Now, next we will see the second method for demodulating AM wave, that is envelope detector. Envelope detector is used to detect or demodulate high level amplitude modulated wave, that is used to detect the modulated signal greater than 1 volt. Envelope detector is the most popular commercial receiver circuit since it is very simple and not expensive. The block diagram of envelope detector is shown below. The envelope detector consists of a diode and a low pass filter. The diode is the main detecting element, hence the envelope detector is also called as diode detector. Diode act as a rectifier allowing current to pass only in one direction, and low pass filter consists of parallel combination of capacitor and resistor which smooths the rectified signal to obtain the envelope. The AM wave, which is given by St, that is equal to AC plus x of t whole is multiplied by cos omega Ct, is applied as an input to this detector. In the positive half cycle of amplitude modulated wave, the diode conducts and the capacitor charges to the peak value of the AM wave. When the value of AM wave is less than this value, the diode will reverse biased and thus the capacitor will discharge through the resistor till the next positive half cycle of the AM wave. When the value of AM wave is greater than the capacitor voltage, the diode conducts again and the process will be repeated. We should select the component value R and C in such a way that the capacitor charges very quickly and discharges very slowly. As a result, we will get the capacitor voltage waveform same as that of the envelope of AM wave, which is almost similar to the modulating signal. Advantages of envelope detector are: first, it is simple and cost effective design, and second one is it is efficient for AM demodulation. The disadvantages of the envelope detector are: it is limited to AM signals only, and second one is its performance can be affected by noise and signal distortion. Now, next we will see double sideband suppressed carrier demodulator. The process of extracting an original message signal from the double sideband suppressed carrier wave is known as detection or demodulation of DSB-SC. The following demodulators or detectors are used for demodulating DSB-SC wave. The first one is coherent detector and second one is Costas loop. When the same carrier signal which is used for generating the DSB-SC signal is used for detecting the message signal, then this process of detection is called as coherent or synchronous detection, and detector is called as coherent detector. The block diagram of coherent detector is shown below. In this detector, the message signal can be extracted from DSB-SC wave by multiplying it with a carrier having the same frequency and the phase of carrier used in DSB-SC modulation. The resulting signal is then passed through a low pass filter which will pass the frequency of modulating signal, and the output of this filter is the desired message signal. Let the DSB-SC wave is given by S of t, that is equal to AM cos 2 pi FM t into AC cos 2 pi FC t. Let the DSB-SC wave be S of t, that is equal to AC cos 2 pi FC t into MT. The output of the local oscillator is given by CT, that is equal to AC cos 2 pi FCT plus phi, where phi is the phase difference between the local oscillator signal and the carrier signal which is being used for DSB-SC modulation. We can write the output of product modulator as product of these two input, that is Vt is equal to Ct into St. Then we can write the output of product modulator Vt is equal to AC cos 2 pi Fct into Mt into AC cos 2 pi Fct plus phi, or it can be also written as Vt is equal to AC square by 2 cos 4 pi Fct plus cos phi whole is multiplied by Mt, or Vt is equal to AC square by 2 cos phi into Mt plus AC square by 2 cos 4 pi Fct into Mt. Or in the above equation, the first term is the message signal or information signal which will be passed through the low pass filter, and the second term will be rejected by this low pass filter. Therefore, the output of low pass filter is V naught t, that is equal to AC square by 2 cos phi into Mt. Now in this way we will recover our message signal MT, and here AC square by 2 into cos phi is the scaling factor. The demodulated signal amplitude will be maximum when phi is equal to 0. That's why the local oscillator signal and the carrier signal should be in the phase, that is, there should not be any phase difference between these two signals. The demodulated signal amplitude will be 0 when phi is equal to plus minus 90 degree. This effect is called as quadrature null effect. Now, the second method for demodulating DSB-SC wave is Costa's loop. This figure represents the block diagram of the Costa's loop. Costa's loop consists of two product modulator with common input ST, which is DSB-SC wave. The other input for both product modulator is taken from voltage control oscillator with 90 degree phase shift to one of the product modulator. The equation of DSB-SC wave is S of t, that is equal to AC cos 2 pi FCT into MT. Let the output of voltage control oscillator is given by C1t, that is equal to cos 2 pi FCT plus phi. This output of VCO is applied as the carrier input of the upper product modulator. Hence, the output of the upper product modulator is given by V1t, which is equal to ST into C1t. Substitute the value of ST and C1t in the above equation, then the above equation will be V1t is equal to AC cos 2 pi FCT into MT cos 2 pi FCT plus phi, or it can be also written as V1t is equal to AC by 2 into MT cos phi plus AC by 2 into MT cos 2 pi FCT plus phi. This signal is applied as an input of the upper low pass filter. The output of this low pass filter is given by V0t, that is equal to AC upon 2 MT into cos phi. The output of this low pass filter is the scaled version of the modulated signal. The output of 90 degree phase shifter is given by C2t, which is equal to cos 2 pi FCT plus phi minus 90 degree, or it can be also written as C2t is equal to sin 2 pi FCT plus phi. This output of phase shifter is applied as the input of the lower product modulator. Hence, the output of the lower product modulator is given by V2t, that is equal to ST into C2t. Now, substitute the value of ST and C2t in the above equation, then we will get V2t is equal to AC cos 2 pi FCT into MT into sin 2 pi FCT plus phi, or it can be also written as V2t is equal to AC by 2 MT sin phi plus AC by 2 MT sin 2 pi FCT plus phi. This signal is applied as an input of the lower low pass filter. The output of low pass filter is given by AC by 2 MT sin phi. The output of this low pass filter has 90 degree phase difference with the output of the upper low pass filter. The output of these two low pass filter are applied as the input of the phase discriminator. Based on the phase difference between these two signals, the phase discriminator produces a DC control signal. This signal is applied as an input of VCO or voltage control oscillator to correct the phase error in VCO output. Therefore, the carrier signal which is used for double sideband suppressed carrier modulation and the locally generated signal, that is voltage control oscillator output, should be in phase. In the last, we can conclude as the amplitude demodulation is critical for retrieving transmitted information in the AM signal. There are various methods exist for amplitude demodulation. Each will have advantages and several disadvantages. The choice of methods depends on the specific requirement, such as signal type, which may be double sideband full carrier, which is standard amplitude modulated wave, double sideband suppressed carrier, or single sideband suppressed carrier, complexity and the application context. Thank you.